Most people start programming by trying to memorize a language. Python, Java, C. But what if I told you that's the worst place to start? Because programming isn't about syntax. It isn't about semicolons or curly braces. Programming is about thinking. It's the art of instructing a machine to solve a problem for you. So today, we stop looking at the trees and finally look at the forest.
At its core, every program you will ever interact with follows the same three-step heartbeat. First, you have input, the raw materials, the data you give the machine. Then comes the process. This is the program, a precise set of instructions that tells the machine what to do. And finally, you get output, the result. You give something in, something happens, and something comes out. Simple, but powerful. But before a program can do anything, it needs a place to keep its data. Imagine trying to cook if your ingredients kept teleporting around the kitchen. Not ideal. In programming, we use variables. Think of a variable as a labeled container, sitting somewhere in your computer's memory. Instead of remembering something complex, you just call it price or age. But here's the question. If I store your age, what kind of data is that? It's a number, and that is a data type. Data types tell the computer how to store the data and how to work with it. You don't put water in a box made for sand, and you don't store text in a space meant for numbers. Everything has its... Now we have data, but how does a program actually decide what to do? It uses conditionals. Think of an if-else, like a traffic signal. If the condition is true, go one way, else go the other. But what if we need to repeat something again and again and again? We don't write it multiple times. That would be inefficient and messy. We use loops. A loop is like a runner on a track. They keep going until a condition changes or a limit is reached. This is how programs become efficient, by repeating intelligently. As your programs get bigger, you don't want to keep reinventing the wheel. This brings us to the DRY principle. Don't repeat yourself. We do this using functions. Imagine a logic capsule. You build a specific set of instructions once, like calculate tax, and then you can call that capsule whenever you need it, as many times as you want. Functions are how we organize our thinking. They take an input, do one job perfectly, and return a result. Simple, elegant, reusable. Now we enter the world of C, what we call the architect's language. C is unique because it doesn't hide how the computer works. It puts you in the driver's seat of the hardware itself. Look at the left side of your screen. Pointers. In C, a pointer is literally direct access to a physical location in your computer's RAM. We call it the architect's GPS because with a line like int asterisk ptr equals ampersand memory, you aren't just naming a value. You are pointing to the exact coordinates where that data lives. It is powerful but unforgiving. On the right, we have structs, or custom grouping. While other languages give you pre-made structures, C lets you build your own data foundations. If you're building a house, a struct is your custom blueprint for the basement and the walls. You decide exactly how every byte is organized. In C, there are no safety nets. Just you, the memory, and total control. Next, we move to Java, the builder's language. Java is designed for enterprise scale, meaning it's built to handle massive, organized systems without falling apart. To understand Java, you have to understand the object-oriented mindset. Look at the visual of the cookie cutter. A class is the blueprint. It's the idea of a cookie. It defines the shape and the ingredients, but you can't actually eat a blueprint. The magic happens at the constructor, which we call the birth. This is the moment you run the code cookie instance equals new cookie. This constructor takes your blueprint and produces an object, the instance. Now, you have a physical cookie you can interact with. In a large program, you might use one cookie cutter, class, to instantiate, create 10,000 cookies, objects, at a massive organized scale. Java is all about creating these reliable, repeatable systems. At last, we have Python, the poet's language. Python's philosophy is simple. Trade verbosity for speed of thought. It wants you to spend your time solving problems, not managing memory addresses. First, look at the Swiss Army knife. This represents libraries, or what we call the shoulders of giants. Instead of building a tool from scratch like you would in C, you simply import power_tool. You're using logic that experts have already perfected, allowing you to build complex apps in minutes. Then there's dynamic typing, or freedom from declaration. In other languages, you have to tell the computer exactly how much space to save for a variable. In Python, you just say data equals changes shapes easily. The language is smart enough to handle the memory management for you. This is high-level abstraction. You skip the strict types and the bare metal details so you can prototype your ideas at the speed of thought. It's about the poetry of the logic, not the mechanics of the machine. Take a look at this. Whether you write printf in C, system.out.println in Java, or just print in Python, the logic is identical. Variables hold your data. Conditionals make your decisions. Loops repeat your actions. Functions organize your logic. Every piece of software you have ever used, from the app on your phone to the rocket guidance systems at NASA, is just a combination of these universal building blocks. Master the logic first, and you can speak any language. This is just the beginning of our journey. In this series, we aren't just going to learn syntax. We're going to solve real problems. We'll take these universal concepts and implement them across Python, Java, and C, so you can see the logic in action. By the time we're done, you won't just be a coder, you'll be a programmer. Are you ready to start thinking differently? I'll see you in the next one.